So here we are going to draw the structures from the given M. And what is the strategy to draw these structures? So here I have not mentioned whether the displayed structure or the bond line structure is required. So we can draw any of these. So first we should observe that what is the parent chain. So parent chain is propane. So we first draw as many carbon atoms as given in the parent chain. So 3 carbon atoms should be there because this is propane. And on the second position, and here fortunately you have equal chances. So from here or from here, this is the second position. On second position, bromo group means bromine is there. So attach the bromine first. And methyl is also there. So attach the methyl. And we have no restriction whether bromo on the top or methyl on the bottom. You can write in either way. Now, is there any other group? Is there any double bond or triple bond? So we can see there is no double or triple bond. So now we should mention how many hydrogen atoms should be there. So if it is propane, then carbon-carbon bonds are single. And if these bonds are single, so we should balance their valency or satisfy their valency by adding hydrogen. So definitely one bond is forming from here. So there should be 3 hydrogen atoms. And similarly for 3 hydrogen atoms are here. So you can write the hydrogen first, then draw the bond line. So this is the 2-bromo 2-methyl propane. Now 2-bromo 4-chloropentane, again pentane. So 5 carbon atoms, 1, 2, 3, 4, and 5. On second position, there is bromo. So Br is written here. Okay. And then chloro on the fourth position. There should be chloro. And there is no double or triple bond or any other functional group. So now we satisfy their valency by adding hydrogen atoms. So how many hydrogen atoms should be there? We know one bond is forming from here, one here, and one here. So there should be 1 hydrogen. And here there is no other, so only 2 bonds are possible on right and left. So 2 hydrogen atoms could be there. And again here, 1 bond from here, 1 here, and 1 here. So only 1 hydrogen could be there. And on the terminal, if no other functional group is there, then you should write 3 and then draw the bonds. So this is 2-bromo 4-chloropentane. Now, again, pentane is the parent chain. So 1, 2, 3, 4, and 5 carbon atoms. On second position, OH is there because all is there. Either on the top or bottom, you can draw in any way. And 2-bromo on the second position, bromo is also there. So now there is no double bond. So we have to satisfy the valency of carbon with hydrogen. So definitely it will form 1 bond from here. So there are 3 hydrogen atoms and there are 2 hydrogen atoms, 2 hydrogen atoms, and here 3 hydrogen atoms. So this is 2-bromo 2-pentanol or pentanol. Now the 2-chloropropane is very easy because this is propane 1, 2, 3. And 2-chloro. So chloro is on the second position. And now satisfied their valency by adding hydrogen. and there are 3 hydrogen atoms. So this is 2-chloropropane. Similarly, now dichloromethane, there is only one carbon atom. Dichloro, it means it has 2 chloro and 2 fluoro groups. So it is very easy. And now this is 2-methyl hex 2-ene. So 6 carbon atoms. 1, 2, 3, 4, 5, 6. And 2-ene means the double bond is present between second and the third carbon. Whether you start from here or here, it's up to you. I'm doing it from there. So on the second position, double bond is mentioned, second and third. 4,5 dimethyl. 1, 2, 3, 4. Methyl is on fourth position and fifth position. Now add hydrogen atoms to satisfy their valencies. So if one group is there, so there should be one hydrogen here and one hydrogen here. But 3 hydrogen atoms are here. And here, 2 valencies has already been satisfied and one from this carbon. So there should be one hydrogen atom. Or otherwise, you can first draw the uh, displayed formula. Then you do this. And there should be CH. And there is CH3. So H3 you can even the CH3 H3 can be written whether on this side or this side as well. So you can write it like this or like this. There's no problem. In a structural formula, there's no problem. So these are the structural formulae of these compounds. But sometimes in chemical reactions and even you may ask to write the bond line formula. So how to convert these into bond line formula? Now see, for this compound, basic chain contain 3 carbon atoms. 1, 2, 3. Every corner is the carbon atom, but it has one more carbon atom. So just like the tetrahedral methane, you can write it like this and write bromo on one first on the position. Remember that in bond line formula, we do not mention carbon or hydrogen atoms, but we must mention other groups or functional groups. Similarly here, 1, 2, 3, 4, 5 carbon atoms are there. So 1, 2, 3, 4, 5. On the second position, bromo is there. So you draw bromo. And 2, 3, 4 position, chloro is there. So you can draw the bond line formula as well. And here again, 5 carbon atoms are there. So for 5 carbon atoms, what will you do? 1, 2, 3, 4, 5 carbon atoms. And here you can draw OH and Br. Okay, so this is your basic chain. Now see, this is your basic chain or the parent chain. This is your parent chain, and these are the groups. And again, this is your basic chain, and these are the groups. And similarly, you can draw here. It is very easy. Propane, only just like this or just like this. And second position, chloro is there. So at chloro there. So you can draw it in both the direction, either in this way or in opposite way, just like this. So both are correct. And here This is the only carbon atom, and we have to mention all the other groups here. So chlorine, chlorine, fluorine, and fluorine. And here 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. 6 carbon atoms are there. A double bond is on between second and third position. So draw the double bond here. And on the fourth position, there is methyl group. Just draw a line like this. And on the fifth position all as well, there is a methyl group. So you have these ways to write the structure formulas or the bond line formula of the compounds. And even you can draw directly in this way. How? Hexane. So you draw the hexane, 2 in on the second and third position. Now see, 1 minute. I think I should give another formula. So take this example for directly writing any structure of the organic compound from their names. For example, you can write 2, 3 dimethyl and hexane, hex 4 in oic acid. So this is the name of the compound that you are to draw the structure. Okay. So how will you do this? If you are directly writing this bond line formula, because it's up to you, you can draw this bond line formula directly as well in A level, not in our Pakistani boards. In Pakistani boards, bond line formula is not introduced at intermediate level. So how to do this? Again, see the parent name. Parent name is hexene. So 6 carbon atoms, 1, 2, 3, 4, 5, and 6. 6 carbon atoms are there. And oic acid stands for that carboxyl group on the terminal. So you can draw it on any other terminal, any one terminal, whether here or here. So this is the carboxylic group. The same carbon atom is used. Do not make any other carbon atoms, because your parent chain contain only the 6 carbon atoms, hexene. And on the fourth position, there is in. It means fourth position means between 4 and 5. So this is number 1, 2, 3, 4, 5, and 6. So if there is 4 in, it means it is between 4 and 5 position. So draw the double bond here. And then in, and we have to write methyl group on second and third position. So second position is this. So this is the methyl group. One line draw here and one line here. So this is the bond line structure of 2,3 dimethyl hexfluoroenoic acid. Or if you are going to draw the structure of this compound, organic structures, then the same strategy use that 1, 2, 3, 4, 5, and 6 carbon atoms. and convert one of the terminal carbon as carboxylic group. Second and third position has methyl. Draw methyl over there, whether on the same position, same side or opposite side. And 1, 2, 3, 4, 4 and 5. Between 4 and 5, there is a double bond. And now satisfy the valency with hydrogen atoms. So there should be one hydrogen atom. There should also be one hydrogen atom. There should also be one hydrogen atom. And there is also one hydrogen atom. And there is three hydrogen atoms. Okay, so you can draw the bond line structure as well as the structural formula of organic compounds.